Hello friends, in the last two videos we have seen derivations of kinematic equations of motion with the three equations, and after that we also saw how to find the displacement in the nth second. Now we have seen two methods. The first one was from that formula for acceleration. The second one was calculus method. These equations of motion can also be derived graphically. I'll just tell you how. Very briefly I'm going to tell you, and after that we are going to move on to motion under gravity. Okay. Now these equations of motion, these three equations of motion which we saw, v is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. These three equations, they are for motion under constant acceleration, uniform acceleration. So my graph is going to be something like this. If I take a velocity time graph, then it is going to be a straight line. So I have velocity here and time here. Correct. As we have seen earlier, u is the initial velocity, v is the final velocity, t is the time taken, time interval, and s is the displacement, and a is the acceleration, right? So if I have those parameters in mind, my graph would be something like this. So it is a straight line cutting the y-axis, okay, that is velocity axis at point A here. Okay, now we say that u is our initial velocity. U is our initial velocity. That means at time t is equal to 0, my velocity is equal to u. That is my initial velocity. And at time t is equal to t, velocity is equal to, let us say, v. Correct. Now this is our time. Now if this is the origin, so that means at t is equal to 0, my velocity is u. So that means this distance would be u. This would be equal to u, correct? And then at this point B here, okay, what is the time passed? Time elapsed is t seconds. And we say that the acceleration is uniform. Correct? So that means gradient of AB, that is going to be my acceleration. So you take gradient between any 2 points here, or maybe these 2 points here, A and B, is going to be equal to A. So I would say gradient is equal to, now what are my coordinates here? Here my coordinates are P comma V, and for A it is 0 comma U, right? And what is the gradient then? Gradient of AB would be equal to V minus U upon T minus 0, so that is V minus U upon T. Therefore I can say V is equal to U plus AT, and this is nothing but our first equation, first kinematic equation. Okay, what about second kinematic equation? See, we say that the gradient of velocity time graph, that will give you acceleration, and area under the curve or area under the graph of velocity, that will give you displacement. Okay, so let us try to find what is the displacement. So now here displacement is going to be the area under AB, correct? Area under the line AB between these two limits here, t is equal to 0 and t is equal to t here, correct? So displacement is area O A B C A O, O A B C O, correct? And what is that area? Is it not this area? If we call this point as D, then it is area of the trapezium. And what is the area of trapezium? It is sum of opposite sides, half into sum of opposite sides, and that multiplied by height. So now sum of parallel sides is OA plus CB. So this area of trapezium OABC is half into sum of parallel sides. Now parallel sides are OA and BC. Correct? And then that multiplied by your height of trapezium, that is OC. Now this is equal to, now what is my OA? Is it not U? Plus, what is BC? BC is equal to, it is CD plus BD and CD plus BD. So what is CD? CD is U plus BD. And what is BD? Into my OC is T. Correct. Now here, now what is BD? My BD is equal to, is it not my 80? Correct. So I'll just write it here, half into 2U plus 80 into T. Correct. And then that is equal to half into 2UT plus 80 square, and that is equal to UT plus half 80 square, and this is my displacement. So that is how we get the second kinematic equation. Now again you will have one question, why have I written BD is equal to 80? Now if you see BD here, BD is equal to BC minus CD, BC minus CD, and what is my BC? BC is equal to V and CD is equal to U, and V minus U, if you see here, is it not 80? So that is the reason why my BD is equal to 80. So that is how we get the second kinematical equation. Now for third kinematical equation, that is V square is equal to U square plus 2AS, or V square minus U square is equal to 2AS. I leave that for you to derive. In the next video we are going to talk about motion under gravity. Thank you so much.